Can you see my screen? Sorry.
Yes, we can see your screen clearly.
Okay. First and foremost, let me introduce myself. My name is Muhammad Naufaldi. I'm a student from Bina Nusantara University, and I'm here to share my research about uh, COVID-19 chatbot using multiple machine learning algorithms and comparing them. So the first part, introduction, is the reason why we make this chatbot in the first place. In the beginning of a pandemic, information regarding COVID-19 is very scarce, and it is hard for the common people to find a factual information regarding that. So something like chatbot that is employed by the official would very help this situation in the beginning of the pandemic. Uh, Chatbot is our chatbot is a product of a task called text classification. Text classification is simply a way to classify a bunch of text or sentences into a predefined category. For example, this is the simplest example that I could think of. The next part, we employed multiple algorithms in our chatbot, and then we compared them with each other. Uh, we have three different algorithms. The first one is the naive Bayes. It's the simplest algorithm out in here. Naive Bayes, quick explanation about it, is the algorithm based on Bayes theorem. And Bayes theorem is basically a mathematical formula to find a conditional probability of something happening. The second algorithm is the support vector machine. This is an algorithm that can be used to classify text too. Basically, it finds an optimized plane that separates the data. This algorithm uses support vector. Support vector is the data that touches the white line, something like the blue one over here, to optimize the place of the plane so it have a large margin between them. The last algorithm that we use is the neural network. Neural network is a computational model based on how human brain works, or more specifically, neuron. So it takes a certain amount of input or a certain part of input, and then if if it's matched, it can activate the other part of the neuron, and so on and so forth until the output is there. This is the solution design of our chatbot. Um, we used a retrieval-based model for this chatbot. Basically, what it means that we have a set of responses that we already make based on the intents of the questions regarding COVID-19. So the first part of the diagram is the user will gives an input into the chatbot, and then the model will use that input to predict the intent. And then the output will be determined by the intent taken from the response, and then will be sent back to the user. This is the data set. Split, we have a very small data set with the total of 254 questions regarding COVID-19. The data set is taken from the IBM website. Also, the reason for the 66 to 33 split is simply because the data set is small, and we want to have more test set than an 80-20 split or 90-10 split. Also, the problem with this data set is the uneven amount of intents. As we can see here, some of them have a very high count, 42 compared to 7. It is not uneven, so it will be solved later in the performance metrics. But first, before we predict what the intent of a sentence will be, we will have to use pre-processing techniques. The first part of this pre-processing is tokenization. It is basically just separating sentence into a bunch of words, and then we remove the stop words. Basically, we remove the words that doesn't contribute much into the intent, such as we or will in this example. And then we have the stemming. It is used to reduce the amount of words in the vocabulary by reducing the words into its root form, such as isolate into isol. Well, it is not reduced to an actual word. Rather, because it use an algorithm, it might not be an actual word. And then the final goal of this pre-processing is the bag of words. Basically, we want to turn these sentences into an array of numbers that map the vocabulary with the number of occurrences in the sentence. This is the three sources of the chatbot output. The first one is the API request. This is output regarding the case count. Usually we took it from open source API in the internet. And then the second output is the predefined responses. It is basically just an output that doesn't need an actual data, something like greeting or goodbye. And then the third part is the web scraping. We scraped from a CDC website for their information. Basically, it's for the question for COVID description, COVID symptoms, or how long should I quarantine, etc. This is the results of the comparison. Usually, we would look at accuracy, but as I previously mentioned, the data is very uneven. So instead, we will use the F-score. Yeah. So the conclusion of our research is that the SPM performs the best out of the three algorithms that we use with the 87% F-score. And we have successfully created a chatbot in Telegram. Although it is currently cannot answer because no one is running the code, but it works. That's it. Thank you for your attention.
Right. Thank you so much, Mr. Naufaldi, for your presentation. Right. Right. We have time for several questions. If any of you has any question, you can open your mic right away and introduce yourself. Right, Mr. Prasapta, you can open your mic.
Okay, thank you. Yeah, very interesting. Yeah, thank you, Mr. Naufaldi. You said that before the data is uneven. Maybe you can tell us more about the data itself. Thank you.
Okay, thank you for your question, Mr. Kuspra Sapta. The data is uneven because we have multiple questions regarding a topic, right? Those topics have a number of questions that were usually asked, but some questions are not commonly asked like the other. Something like case count would usually be asked more by people than something like quarantine before. So I think this affects how the data set is. And basically we have a large number of questions regarding one topic, and then the other topic we have a small amount of questions. Yeah, that's why it's uneven. I hope that answers the question.
Okay, thank you.
Thank you so much, Mr. Kusprasapta, for your question. Is there anyone else that wants to ask Mr. Naufaldi about his application? Right. Since there's no one questioning at the moment, I would like to question you as a moderator.
Okay.
I would like to ask you something actually that I find quite interesting. Is that you told us that the data set itself is uneven. So, and the data set itself is actually a bunch of questions regarding COVID-19, right?
Yeah.
So my question is that how can but that unevenness is can actually be can actually be added, in my opinion, due to how the nature of the question works. You can you actually put out your own question regarding COVID-19 to your own data set so that it balance out? If not, why cannot?
Okay. Thank you for your question. I think, yes, the answer is we could add some questions regarding COVID-19 ourselves, but the pattern of question is different from people to people. People write differently, right, in the internet. Some of them have weird grammars and stuff. So I think it is way more helpful if there are other people that contribute to this data set. And for our research, we didn't ask multiple people regarding these questions because we don't have the ability to yet. So we have to work with the data set as is for now. I hope that answers your question.
See, because I can actually think of something that can make the data set more popular, maybe by Google Forms or maybe just by asking the friends, your circles. Yeah. Hey, that's all. Thank you so much, Mr. Naufaldi, for your answer.
Thank you.